All right, so we're going to continue on with the mini bike project. And we're going to start talking about assemblies top down. Top down is where we already have the assembly and we actually create our components inside that assembly. So for the mini bike, we have our frame created, and on this canvas page, we have our engine. We've got our mini bike engine right here. We will take this engine and we will position it the way it's been described here. And then what we're going to do is we're going to make an engine mount, and we're going to create that engine mount in the assembly. We'll create part of it outside of the assembly, and then we will create the rest of it inside the assembly. So whereas before with the bottom up method, we had all of our components already created. They were finalized. We didn't do any sort of editing in the assembly. Now we are going to actually finalize the components and do some editing in the assembly. This isn't the greatest method. It certainly works, and it happens all the time that we sort of design and create as we go. So let's go ahead and look at what we got. So we have a engine mount and engine location information. The mount is 10 gauge mild steel. You gotta be careful when you are looking up the thickness of sheet metal. So I could call 10 gauge mild steel one thing, and I could go to a sheet metal fabricator and ask them for some 10 gauge mild steel, and they could give me a completely different size material. When you're looking up sheet metal thickness, you'll get a whole wide variety of answers. Best thing to do is to look at reliable sources. And then also, if you're going to be using sheet metal from a supplier or from even McMaster-Carr or anything like that, it's best to just look at what they call 10 gauge sheet metal and use that thickness if that's what you are going to do. If you are creating a drawing, you're creating a part where you want to specify that you're using 10 gauge sheet metal, it's best to also add the dimensional thickness to what that is. So the sheet metal size that we are going to be using are the 10 gauge that what we're going to be calling 10 gauge mild steel is 0.1345 inches thick. Once we have this component modeled, we are then going to create a drawing of it. And so you're going to be submitting 2 things to the Dropbox for this assignment. So let's go ahead and get started. So I've already got the homework 12A assignment that we did opened. This has the left and right side bike frame. We are going to be adding components to this assembly. And the first item that we are going to add is going to be our engine. Now the engine is available, it's on Canvas. Go ahead and download that. Remember, the engine and the engine mount that we are going to create all need to be in the same folder as the bike frame components. So just make sure that you have everything in the same folder. You're saving everything to the right location. So I'm going to go to Assemblies. I will add component. I'm going to open and select our component, and I want the engine. I'll just position it out here in space, and I'm going to rotate this because we want the crankshaft to be on the left-hand side. And then we will hit OK. And I'm going to move this a little bit more so that it's kind of positioned sort of where it needs to be. That's close enough. So we're told that the end of the crankshaft is 3¼ inches from the bike center plane. And that bike center plane is the plane that splits the 2 bike frame components. So that's actually going to be this XZ plane. So we're going to want to add an assembly constraint. We want a distance. We want to select the end of the crankshaft, so just that face right there. And then we want to select this XZ plane. And the dimension that we're given is 3.25 inches. We'll hit apply because we're going to do another distance. So we're told that the center axis of the crankshaft is 16.5 inches in front of the bike reference plane. So we want to select the center of this crankshaft, and that's just going to be the center line. And that's 16.5 inches from this back plane, and the back plane is going to be this YZ plane. And that's going to be 16.5 inches. Now we have not completely constrained this, so we'll still be able to move up and down, and that's when the engine mount comes in. So we're going to mount this onto the engine mount, but we don't have that done yet. So we're just going to move it up, and we're going to hit OK. So now we know that our engine mount needs to be about right here in this area. So let's go ahead and create that engine mount. While we're still in our assembly, what we want to do is we want to create a new component. We'll leave all this default, that's fine. We'll hit OK. And now we have model 1. Want to make this our work part. So I can either right click and say make work part, or I can double click. Remember, a good indicator is that it's bold and everything else is grayed out. If we actually had a component for this model, it would still be with that shaded with edges, but we don't, so everything is grayed out. And we'll go ahead and do file save. We're going to name this homework 13A, and then your UUID. Again, we want to make sure that we are saving this in the location where everything else is at. So everything in this assembly should be in the same folder. And we'll hit OK. Now to start off our engine mount, I'm actually going to open this up in a window and start with a sketch and the way that we're used to starting these models. And then we'll come back into our assembly and we will fine-tune the position of everything. So I'm going to right-click on our engine mount, and I'm going to say open in window. And then I'm going to go to home, and I'm going to do a sketch. I want to do the sketch on the front plane. Hit OK. And so we want to make this engine mount. This engine mount is made out of sheet metal, so it's going to be bent. So it's going to have rounded edges to make this engine mount. So I want to go to Profile. And just somewhere on this x-axis, I want to make the one side of our engine mount. I'm going to come up, and remember, if we press and hold on a point that we just made, we can create an arc. Not worried about the exact dimensions right now. I'm just making the part. And so we only want to do one side. So what I want to do is I want to do make equal, make sure that we have equal radius, and I want to select these two radii. Hit OK. And I'm going to go ahead and dimension one of them, 0.1345. and I want to do an offset. I want the offset to be the thickness of our sheet metal. So we want to do the 0.1345. And I want to dimension this so that I want the direction to be going out. So I want us to have we drew the inside edge and we use the offset to create this outside edge. Make sure that we have create persistent relations checkmarked. We'll hit OK. Now what we need to do is connect these at the bottom. So we'll come up to line. I'm going to turn off my point on curve. So now I can access these endpoints a lot easier. And when I connect this last one, the whole thing turns blue. So we actually have a 2D boundary here. Now what I want to do is I want to make coincident this endpoint with our origin here. And then also we were told that the mount itself is 0.75 inches tall. So now I'm going to mention from the top to the bottom of our engine mount. Now I want this to be 0.75. Now we should have sketches partially defined with 7 movable curves. And those 7 movable curves are because we have not fully defined our part here. So we can still move this left and right. And that's where we want to be. We don't know exactly how long this is going to be until we actually put it in the assembly and we figure out how long we need it to be. But a quick check to see if there's anything else that we've missed is we can actually define this dimension here. We can just put in a random number and we should have sketches fully defined. If we have that, then we are good to go. I'm going to delete that dimension. We can still have 7 movable curves. Now, I know that we've said since day one that we should not have a sketch that is not defined, but that's what we're going to do. We're going to leave this sketch partially defined, knowing that we are going to come back and define it. So we'll hit finish. And we also need to extrude this. Let's extrude it 5 inches. Again, that's another value that will be changed in the assembly. We don't know how long it needs to be yet. When we got to this point, there's nothing more that we can do. So we're going to go back into our assembly. And we can see that, oh, well, there's our part. And we need to move this, position it so that it is underneath our engine. So instead of our work part being the engine mount, we want our work part to be the assembly. And we're going to create some constraints on our engine mount to locate it a little bit better. Go to assemblies, assembly constraint. That is going to be located on these tubes. So I'm going to go to touch align, and we'll go to a touch. I'm going to select the bottom of our mount, and then just select one of our tubes. You can hit apply. So that's going to keep it on the tubes there. But this part can still rotate. You can move all the way around. So I want to make sure that it stays level. So I'm going to create a parallel constraint at the top of this part to this XY plane. Hit apply. So now it has to stay with that in that plane, but it can still rotate side to side. So I'm going to add another parallel constraint from this this back face to the Z or the YZ plane. Hit OK. So we should be able to move this part forward and backward, side to side, but we should not be able to rotate it around. And that's okay, what it's doing right now, because it's just moving backwards and forward, side to side. That's fine. I just don't want it twisting and rotating. Now what we need to do is we need to move it. So that it's underneath the engine. Doesn't have to be perfect, because what we are about to do is change the size of this so that it fits underneath the engine. And so what we're going to do is we want to make this our work part. So we're going to double click on that, make it our work part. We can go to the part navigator, and this is where we can actually work on our part inside of the assembly. So I'm going to go into the sketch, and I want to change the length of this part so that it's long enough to fit underneath the engine. Right now we are at about 5 inches, and this should be moved around so that we are stopping at one edge and we can move it back, but this is okay. We'll make this work. So what I'm going to do is I'm going to move this back, and to move it back, we have to be in the assembly. So I'm going to move this back. It's about right there. Now I can go back in and lengthen this to what we need. So it's 5 inches. Let's try 6. Try 7. Still not there. 8. Close. Let's try 9 inches. 9 inches looks good. So what we want is to be able to fully support the engine. So we've got holes here and holes here, and that's where it's going to be mounted to. So we want to make sure that we have enough material past the engine, but not so much that we are wasting material, and we don't want to go so far here that we're hitting where this bend is at, because we need to come in here and weld on this engine mount. We can't really get into that weld joint if we are at that curve location. So I'm happy with that 9 inches. I'll hit finish. And now what we want to do is we want to look at this extrude. So we want is extrude. We want this to be extruded enough so that we have enough material on either side of the tubes to get a weld down. And we also want to make sure that we have enough material that we can actually attach the engine to. So we're at 5 inches now, which is not quite enough. Do 6, not quite enough yet. Do 7. 7 looks pretty good, but I don't like how this is not overhanging like this side is. So I'm actually going to do 8 inches here. And I'll move this part over. I'll go back to our assembly. And I want to move our part over just a bit. So now we have material overhanging on both sides, on all sides, and we have enough material that we can create our slots for our holes. Now that I'm pretty happy with where this is at, I'm going to add some more constraints to lock this in position. I will create a distance, and from this back edge to the back plane, and I'm just going to hit OK. I'm only adding these in to make sure that the part does not move. I'm going to do the same thing, but from this face to the XZ plane. And I'll just hit OK. Again, that's so this does not move. And then the last thing that I want to do is I want to actually position the engine to be on the mount. So I'm going to do another assembly constraint. I want to do a touch align, and I'll do a touch. And I want one of the bottom face of the mounting location. So we've got 1, 2, and then 3, 4. You can just pick any of those. And then just the top of our engine mount. Now you can see that it flipped upside down because it doesn't know what we're trying to do. And we can just reverse last constraint, and it's going to position it on the top right there. And we can hit OK. That's what we want. All right, so now that we have the engine mount located where we want it to be at, we need to make the slots for the bolts. And so this is where on the engine where the bolts are going to be going. So we've got a hole here, we've got a slot over here for make sure that we have adjustment and so that we have some clearance. Same thing on this other side. We've got a hole and then we have a slot. Now what we want to do is create a way to link this geometry to the engine mount. And the way that we're going to do that is with the wave geometry linker. So what we want to do is we want to make the engine mount our work part. And we want to go to the wave geometry linker. There's a few ways to do this. I am going to use the face. And I'm going to flip this upside down so I'm seeing the bottom of the engine. And I'm actually going to come over here to our assembly navigator and hide our engine mount. I want single face. And I want to select the face of all the bottom sections of where the holes are going to be. I'll select this face, this face, this face, and that face. Make sure that we have associative selected. Make sure that fix at current timestamp is not selected, and we'll hit OK. Go and flip this back around. Show our engine mount. And to complete this, what I'm going to do is I'm going to open this. Actually, it's already opened up in a window, so I can just come over to this. And we can see the geometry or the faces of that engine mount. What the wave geometry linker is really good for is that if we were to move this engine in space, say instead of the 16.5, we've moved it back to 15, the faces that we just created would update in our model. And so we can create geometry that's sort of connected to these holes, and they'll move with the model. So any changes that we make to the geometry that's associated with these faces will change on our part as well. And that's what's great about using the wave geometry linker. Because if we didn't use that and we just kind of positioned the holes, if we were to make this, if we were to move this at all, we would also have to move those holes. So this simplifies the process as far as making changes. And so now we need to make our slots. We want our slots to be going from left to right here. So I'm going to go to home. We're going to make a sketch. We're going to sketch on the top plane here. Hit OK. And I'm going to make one slot, and then I will use the pattern feature to create the others. So I'm going to go to Profile, and I'm just going to rough out a slot. And I want the edges of the slot to be touching the holes, or the hole for the bolt. I'm going to come here to our make constraints, and I want the make tangent. I'll select this line, and then I want to select the inside circle that we have here. If you cannot access this circle, come up here to your filters and make sure that you have work where you're within work part only. If you're within the active sketch, you won't be able to access those. You need within work part only. So select one of the lines and then make it tangent to the circle. I'll hit apply because I'm going to do the same thing for this bottom. And I'll hit OK. Now what I want to do is I want to position the center of this line, the midpoint of this line, to be at the edge of this circle here. So I'm actually going to do a make coincident. And I'm going to select that midpoint. And then I'm going to select the edge of the linked face. That's going to, and I'll hit OK. That's going to move it so the midpoint is right where that tangent constraint is at. And then we can dimension this slot. Now the slot dimension might be slightly different for yours depending on the size of the engine mount. So what we don't want is our slot to be going into where this bend radius begins. We also don't want it so small that we don't get a lot of movement. So it's going to be a little bit of a guessing game here a little bit. So I know that the 1 3/4 is a bit too large. So we can come down to, let's say, 1.5. And 1.5, it's pretty good. It's a little close to the bend radius. This might be something that we come back and address later. We'll let it slide for right now. Sketch is fully defined, so we're good. I'm gonna hit finish. And I want to extrude this slot. Make sure that we're going into the material. We are subtracting, and there's gonna be a through slot. We can hit OK. You still see this because this is the linked face. We'll hide that in the layers here in a second. That's okay for right now. What we want to do is we want to pattern feature this component. We want a linear. The feature that we want to pattern is going to be the slot that we just made. Specify the vector for the first direction. And we'll go ahead and select so we're moving in this direction. The count we have as 2, because we have 1, 2. And our distance is we're actually going to measure this because we don't know exactly how far apart these holes are. So we're actually going to measure, but we unfortunately don't have access to, we want to go from point to point. We unfortunately don't have access to the center of the hole. So if we do the outside edge to the inside edge, that gives us the same distance as from the midpoint to the midpoint. So what we're going to do is select the edge that's pointing away from the hole on this side. And then on the other hole, we want to select the hole that's facing this hole. So it's going to give us the distance from this outside edge to the inside. We'll hit OK. And you can see that we have gone from the center to the center. And we're also going to use a second direction here. So when you select the box for a second direction, so it'll give us an array. Our count is 2. We're still using count and pitch. And our distance, again, we are going to measure. And we want the center of this circle to the center of this slot. And if we look, we can actually access this center line, or the center point of this line, which is horizontal to the center of the slot. So we can select the point on this side, and then we can select that midpoint on the other slot. And that gives us the distance from midpoint to midpoint. Specify our vector. And we can see that our little cubes are all in the right locations. And we can hit OK. That looks right to me. So we can go and hide these faces. Go to move to layer. We want to select the sheet body. Select all. Hit OK. Put those on the sheets layer. We will apply that. We'll select new objects. Want to select all the sketches. Hit apply. Select new object and our datums. Now we can hide all of that. And we have a nice, beautiful engine mount. If we go to our assembly, on the next video, we will go over creating a drawing for the engine mount.